Hello students, welcome back to the channel Maths Insider. Today's topic is about a quadratic equation and its discriminant and nature of roots. So what we're going to learn from this video are, we will learn about what is discriminant. So from the given quadratic equation, how we can be able to identify which one is the discriminant, and then how to find the discriminant. So one is what is discriminant, and second thing is how to find that discriminant. So we have to use the formula to find the discriminant, the value of the discriminant, because from that discriminant we can able to see the nature of the roots. So without actually solving the quadratic equation, we can able to find what are the different nature of the roots depending on the value and the sign of the discriminant. So that we're going to learn in depth in this particular video, and that there is some important exam tips which we will see, and then we will go through the quick revision. This is a very important chapter, a lot of question comes, so please watch this video till the end. So let's get started with this particular topic. So first of all, what is a discriminant of a quadratic equation? So let's see. So for the given quadratic equation, say ax square plus bx plus c equal to 0, for a given quadratic equation, we have derived the formula in the previous video or in the last video. What we have derived for any given quadratic equation in standard form, the roots of the equations are given by x equal to minus b plus minus root over of b square minus 4ac by 2a, where a, b and c are all the constants of the given quadratic equations. Now, the discriminant of the given quadratic equation is given by d is equal to b square minus 4ac. So the value b square minus 4ac under the root, that is the discriminant. So this value help to understand the nature of the root. So that's why this is important. So without actual solving the problem, if we find this value of d, we can able to find the nature of the roots. So we can write the equation as x equal to minus b plus minus root over d by 2a. So this d is equal to b square minus 4ac. So only this small part b square minus 4ac can help us to tell about the nature of the roots. Now we will go to all the different nature of the roots. So they are divided into three important cases. So case 1, when d is greater than 0. So if the value of the d is greater than 0, a positive number, then the roots are real and different. So whatever roots we will get for this given quadratic equation, they will be different. We will always get two roots, so they will be different and they are real roots. And second is two distinct solution, meaning we can get two roots which are distinct, say x1 and x2. So they are not the same, they will be two different root, will get it, and they are real. Now let us take an example to see. For a given quadratic equation, say ax is we'll write one example, x square minus 5x plus 6 equal to 0. So let's calculate the d first, discriminant, which is equal to b square minus 4ac. So from this quadratic equation, we find a is equal to 1, b equal to minus 5 and c equal to 6. So first you have to correctly assign this constants, and then you have to put the value in this given equation. D is equal to b square minus 4ac is equal to minus 5 square minus 4 into 1 into 6, that is 25 minus 24. So the value of d is positive 1. So since d equal to 1 is greater than 0, so the two roots, so the roots which we'll get, they are real and they are different roots. So this is case 1. Now Let's take the next case, which is case 2. So if d is equal to 0, so in the first case it is greater than 0, now it is equal to 0. Now if d is equal to 0, then the roots are real and they are equal. So roots are real and they are equal, and one repeated solution we will get from that equation. So both the roots are equal, so we'll get, so in the case 1 we get x1 and x2 two different, but in this case we'll get the two same roots which are equal. Let's take an example. X square minus 4x plus 4 equal to 0. Now let's calculate the value of b square minus 4ac. Let's calculate the value b square. Here a is equal to 1, b is equal to minus 4 and c is equal to 4. So assign it correctly, and then let's put the value of a, b and c in the given equation. So d is equal to minus 4 square minus 4 into 1 into 4, which is 16, minus 16, that is equal to 0. So since d is equal to 0, so the roots are real and equal. So they are real and equal. So we get the second case where d is real and equal. Now case number 3, if d is less than 0. So if d is less than 0, then the roots are, there will be no real roots. So roots are not real, number 1, and roots are said to be imaginary. So roots are said to be imaginary. So no real roots and roots are imaginary. Now what is this imaginary number? So let us see what is this imaginary number. So this imaginary number is a number which is, like for example, root over minus 1 or root over minus 3. So anything under the square root, negative number under the square root gives the imaginary number. So minus root over minus 1, root over minus 2, etc. These are all the imaginary roots. Now let's take an example. X square plus x plus 1 equal to 0. So what you will get, let's calculate the discriminant. D is equal to b square minus 4ac. Here a is equal to 1, b is equal to 1, c equal to 1. So now putting all the value for the given equation, d is equal to b square minus 4ac. So what we will get, d is equal to 1 square minus 4 into 1 into 1, which is 1 square minus 4, which is minus 3. So here d is equal to a negative number. So if we put d in the formula, we get x equal to minus b plus minus root over minus 3 by 2a. So this minus 3 under the root is the imaginary number. So this is not a real number. So if d is less than 0, so since d is less than 0, so there is no real solution and they are imaginary roots or imaginary solution. So these are the three important cases that is come out from the nature of the roots. So now what we will do is that we will just, in order to keep the thing in mind, we will put all these cases in a simple table, and so that it will be easy for you to assimilate the whole concept of these different cases, and you can able to remember this when solving the problem. So remember the table. So what is there? First, when d is greater than 0, so d is a positive number, so roots are real and distinct. So two different roots will get x1 and x2. Now if d is equal to 0, then roots are equal, so we'll get both the roots are same, say x. Now number 3, what we'll get, if d is less than 0, no real roots, so roots are imaginary. So these are the 3 important things, keep in mind. So we have put it in the table to make you remember. Now, why this is important? Why we have to find this discriminant? So this is a very important things. So this is important so that we can able to predict the solution without actually solving the problem. So without solving the problem, we can predict the solution. It will definitely save time in the exam. Otherwise, we have to calculate step-by-step method. We have to get the factor and then make it 0 and then find it. Instead of that, we can directly use this and we can able to predict. So understanding the type of graph. So from that equation, if we know the discriminant, we can able to see in the graph how that particular equation looks like. Now exam tips: always calculate d correctly. So take care of the sign plus minus as well as the minus before b. So calculate d is equal to b square minus 4ac for the given equation ax square plus bx plus equal to 0 where a is not equal to 0. Secondly, show the steps clearly. So for each of this value of d, you just try to recall all the 3 different cases and write it down. Then write the conclusion properly depending on the value of d which you will get after the calculation. Now, whatever we have learned so far, let's recap. Remember the formula d is equal to b square minus 4ac, and also remember the 3 different cases which arise on the value of the d, that is the nature of the roots. So if d is greater than 0, roots are real and distinct. If d is equal to 0, roots are real and equal. And if d is less than 0, the roots are not real and they are imaginary. So these are the 2 important things you have to remember for this. I think you have enjoyed this video and you have got the concept of the discriminant and how to use the discriminant to find the nature of the root. In the next video, we'll going to practice more of such problems using the discriminant, how we can able to derive the nature of the roots. So this is the whole thing in gist. So I hope you have liked this video. If you like, please share with your friends and subscribe. See you in the next video. If you have any question, put it in the comments. Thank you.